Hey guys, welcome to Spotted Hyena. My name's Steve, and today we're going to be taking a look at Docker. So in this series, we'll be taking a look at Docker, how Docker works, going through what Docker is, and the different components of Docker. And then later on in the series, we'll take a look at installing Docker and how we can use Docker within a live environment. So in this video, we'll be looking at what Docker is, what containerization is, how we go through an image and build that, and then some facts around Docker usage. So what is Docker? Docker is an open source platform for developers and sysadmins to build, ship, and run applications. It allows you to turn applications into a small image that can then be run on any Docker platform as a container. Docker basically eliminates the issue whereby an application may not run on one computer, but it may run on another. So for example, your developer is working on his application on his computer and it works perfectly fine. But then he asks a colleague to take a look and troubleshoot a bug, but his colleague can't even get the application running. And that's because he maybe doesn't have some libraries installed on his computer that the other developer does. And likewise, when you move it to live on your server, you might not necessarily have the application required on the server in order to run your new program that's been developed. So Docker basically takes away that complexity, and it means that if you can run a container on one of your Docker images, you can run it anywhere on any Docker server with that same Docker image. So it does make things a hell of a lot easier in that sense. So we'll now take a look at what is containerization. One of the things that people get confused quite a lot is that they see containers as being virtual machines. That's true in a sense, but they're not virtual machines. You know, a virtual machine, as you can see from the image on the left-hand side here, you've got the host that sits at the bottom with its operating system, which is a hypervisor, so something like VMware or XenApp or something along those lines. And then you have your virtual machines sat on top of that. Each virtual machine has its own operating system as well. And then you have the binaries and libraries for your application. And then you have your application sat on top of that. So as you can see, in a normal virtualization platform, you've got two operating systems, and then you've got all of your binaries and libraries and your applications. And in this scenario, you end up with longer boot times because you first have to boot up your hypervisor, then you have to boot up your guest OS, and then your application has to start. In another problem that you see is that with traditional virtualization, you've got multiple guest operating systems, so you've got the same files repeated over and over again, which uses up space unless you've got some sort of deduplication on your storage in the back end. So you can see there's quite a few things that may not be ideal about virtualization, and containerization resolves a lot of these problems. So if you look at the image on the right-hand side, you can see that we've got an example of containerization. So we have our physical host, then on our physical host, we install our operating system. So that could be Linux, you know, Red Hat, CentOS, Ubuntu, or something along those lines. And then you install Docker. So Docker is just an application that sits on the operating system. And then we create what are called containers. A container is basically a location to store binaries and libraries and to run your application from. So it is similar to a virtual machine in that it's a contained piece of code, but it doesn't have its own operating system. It shares the operating system with the host OS. However, it is abstracted. Therefore, if you install, say, a different version of Java on the host OS, but you need an older version of Java running on one of your containers, then you can do that and it won't cause any problems with your application. So this is perfect if you've got a lot of different versions of applications that run on different binaries and libraries, because they won't interfere with each other being on the same server. You can also have storage savings here. You don't have a guest OS on each of your containers. You just have the binaries and libraries that that container requires. But further to that, you also have the binaries and libraries, if they are used in different containers and they're the same, so the versions are the same, the files are the same, then Docker is clever enough to be able to deduplicate those files. So you'll only have one copy of every type of file on there, which makes it a lot more friendly for storage savings. You've also got those improvements on being able to have different versions of binaries and libraries, which is a great bonus. One big difference as well is that Docker is able to manage the resources that each container uses. So that means that if, for example, app 1 needs 2 gig of memory, but then app 2 needs 5 gig of memory, that's fine, it will use that. But let's say the next day app 1 is using 5 gig of memory and app 2 only needs 2 gig of memory. Well, Docker will manage that for you. Docker will make sure that the applications are only using the resources that they need to use. Whereas with virtual machines, you allocate a set amount of memory. So if you set 6 gig of memory on a virtual machine, then that virtual machine is always capable of taking 6 gigabytes of memory. Same with CPU. If you allocate 2 CPUs to a virtual machine, it can only ever use those 2 CPUs. It can never use more. It could use less, but it's unlikely to. So you also have additional resources that are available to you because Docker is managing all of that for you. And you don't have to manually change your virtual machines all of the time with new memory allocations and new CPU allocations. So a Docker container is created from a Docker image. So the question is, how do we create a Docker image? Well, to do this, we create a Docker file. This file contains the configuration that describes how an image should be built. In essence, it is a definition of what is required for an image to work. But it is not an image itself. The file would define things like what the base image is. So should it be Nginx? Should it be CentOS? Should it be Node.js? You can specify the specific application that you want to use. You don't have to say an operating system such as CentOS. So if someone's already created an image that has Node on it, then that image will be better because it will have less bloat in it. It won't have the full operating system files in there. It'll just have what is required to run Node. And you can get these from the vendors. So Node themselves will likely have their own Docker image, or you can get them from Docker Hub. And then what you can do is you can define commands. So if you need to install additional binaries and libraries on top of the ones that Node install, then you can run commands in the Docker file, which will basically tell when the image has been created, it'll tell it to use these additional files. And then you can copy files to the image, such as your applications. However, there are other ways that you can deal with your application depending on how you want to update your files and things like that. So then that's it. Basically, you can run a command in Docker that will use the Docker file to build a Docker image, and that Docker image will then be available within Docker for you to use. And then from that, you can make a container. It's important to remember the Docker file doesn't actually do anything to do with the image. It just provides the information in order to build the image, and that is it. It's not included in the image. So if you get rid of your Docker file, you won't be able to do any new changes to your Docker image. You'd have to create a new Docker file and potentially create a new image depending on how much has changed. So now we'll take a look at some facts from Docker. So why would you want to go and start using Docker? Well, Docker adoption has been up by 40% in just 1 year. 40% of Docker organizations use orchestration. This means that you can automate things a lot easier, make things much easier on your developers, and reduce your costs at the same time. Larger companies are leading on the adoption of Docker. And there's a lot of large organizations, they're moving their legacy applications or they're moving new applications into microservices, which allows them to better scale their environments. Containers churn about 9 times faster than VMs. So this is quite a good stat. It shows that when you're developing, you can just fire up a container so fast that you don't need to worry about the configuration being wrong or anything like that, which you do with the virtual machine. And it's a lot quicker to spin up a container and to destroy a container and then to spin it back up in exactly the same state that it was in before. So organizations find that that is a winning situation. It reduces the amount of time to get things from development and into production. And then finally, you've got the average company that uses Docker ends up quintupling its Docker usage within just 9 months. So that's a massive, massive increase. So they start building their application and then they realize that actually it's so much easier to run their applications within Docker that they're starting to increase the amount of applications that they have in there. And they're also able to spin up multiple Docker containers and balance their load across all of those, and then balance that load across multiple Docker servers across creating what are called swarms. So as you can see from all of this, Docker usage is growing rapidly within organizations, and more companies plan on using Docker for their applications in the future. A massive 78% of organizations surveyed by Docker said that they're planning on doing this. And this leads to potential opportunities for developers and sysadmins. If you've got experience in Docker and microservices, then most organizations will be willing to pay quite a lot of money to get your skills into their house and to help them move their applications and their microservices across to Docker to allow for better scaling and better performance and quicker development for their customers. And you're likely to get paid a lot of money to be able to do all of this as well. So that's it for the introduction to Docker. Thank you for watching. Hopefully this video has been useful to you. If it has, please hit the like button, please subscribe, and hopefully I'll have the next video out to you guys in the next week, where we'll be installing Docker and we will be looking at some basic Docker commands and getting our first container test up and running. Thanks again for watching, and I'll see you next time.